So graphing with square roots is actually the same as graphing our parabolas or our quadratics here. Remember, that means it has an exponent of 2. Well, a square root, so the square root of 25, is the exact same thing as taking 25 and raising it to the 1/2 power. So we can get started with the exact same vertex form and apply it with our square roots. Now, after that, we have to alter a little bit, and we'll show you what's going on here. But let's look at this. If we're going to graph here, y equals the square root of x plus 3, and then minus 2. Well, that's the exact same thing as writing it out in this particular form, which looks just like our vertex form. So we can use that here. We're going to have our negative 3, we're going to have our negative 2, and again, we're taking the opposites. Now, square roots, though, don't make that U shape that we see with our parabolas. So we're not going to be able to use our 1a, 3a, 5a. So we are going to end up using what we refer to as our parent function or our parent graph. And the idea here is when we think about taking square roots of things, I'm not going to focus on the adding the 3. I'm not going to focus on the subtracting 2 off to the side. I'm just going to focus on the square root of x. And again, this is our parent function. So if I'm going to take the square root of x, I only want to use things that I can take the square root of. I can take the square root of 0. I can take the square root of 1. Square root of 2, no thank you. That's a decimal. Square root of 3, Square root of 4, yes please. And let's get one more in there. 5, no. 6, no. 7, no. 8, no. 9, yes, exactly. So what this allows me is if I take the square root of 0, I get 0. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. And what I can do is I can start making adjustments here. So, for example, the x, we know, all right, we're going to go to the left to that negative 3. So we're going to be subtracting 3 each time. 0 minus 3, negative 3. Yeah, there it is. All right, 1 and then minus 3. Well, that's a negative 2. 4 minus 3, well, that's a 1. 9 minus the 3, that's going to be a 6. These are going to be my new x coordinates. So I use the parent function and then I adjust it based on the situation. Off to the side there, we have the minus 2. So over here, I'm going to subtract 2 each time. Well, if I'm at 0, I'm now going to subtract 2. If I'm at 1, let's subtract 2. That's negative 1. 2 minus 2, 0. 3 minus 2, there's my 1. So now I can take my new x coordinates, my new y coordinates, and I can go ahead and plot my graph here. Let's see what we've got going on. So the order pair negative 3, negative 2. 1, 2, 3, go down 2. There we are. Negative 2, negative 1. Negative 2, negative 1. There we go. 1, 0. So to the right 1 and then add 0. And then 6, 1. So to the right 1, 2, 3, 4, 5, 6, and we're going to go up 1. So we're kind of getting that kind of look that we're after there. We kind of get like that little hook. In general, your square roots are always going to do something along those particular lines. But yeah, that's the idea behind it, is all we're doing is we are shifting it around. If we think about the parent graph, it originally started at 0, 0. It would be 1, 1, right 1, up 1, all right, to the right 4, 1, 2, 3, 4, up 1, 2, all right, to the right 9, all right, whoa, way out there, and then up 3, all right, so something right around there. So that's the idea, but what we've ended up doing is taking it each time, moved it 3 spots over, all right, and then ending up moving it down 2 spots. 1, 2, 3, down 2. All right, moving it over 3, down 2. Here we go, over 3, down 2, and we're going to match up. So that's how our parent functions are used. Okay, the other thing that goes along with this is, well, what about if someone else shows up in front? Like I used to do my 1A, 3A, 5A to find my points. Well, all right, we're going to show you how we adjust that here. Create some more space. In our table that we're going to end up seeing, we always are going to start with that parent function with that x and the y. And then remember what we do is we take the opposite, all right? And then over here, it's called ay plus k. Yeah, I know it's very mathematical here, but let's show you where it's coming from. Let's say we want to graph the ordered pair, the function here of 3 square root x plus 1 and then plus 2. All right. So, same thing goes on order. Get the parent function going. We're just working off the square root of x. So 0, 1, 3, 9. Take the square roots of them. 0, 1, 2, and 3. And these are going to be automatics. We're always going to start here with those particular parent functions. The opposite of adding that 1 is that subtract 1. So I like to put that up there, and a lot of times I like to actually say what I'm doing, but you can put the minus sign that's there. So 0 minus 1, negative 1. 1 minus 1, 0. 3 minus 1, 2. 9 minus the 1. There's my 8. Now, here we go. A times the y and then plus the k. So we're going to multiply 3 times the y, because this is our a who's out in front, just like with our parabolas we saw. And then this k is this person lingering out to the side, so plus 2. So now we just plug it in. If y was 0, 3 times 0, 0 plus 2, that's a 2. Plug in the 1. 3 times 1, 3. Plus 2, hey, that's a 5. Plug in the 2 now. 2 times 3, 6. 6 plus 2, 8. One more, probably not going to fit on the graph nicely. 3 times 3 is 9, plus 2, there's your 11. So again, hello and hello. That's who we are going to be graphing. So let's come on off to the side here and let's throw some of these down. Negative 1, positive 2. There we are. 0, 5. 0, 1, 2, 3, 4, 5. There we go. 2, 8. To the right, 2. Now I'm at 5, 6, 7. That takes me up to 8. That's there. My goodness. 8, 11. Somewhere. All right. But here we go. There we go. Arrow on the end. Now, the whole reason why it stops right here is because, remember, we can't take the square root of negative numbers. And that's what's going on here at the very beginning. Underneath this with the x plus 1. That's why, for just a square root, the smallest square root we can take is 0. 0 is technically not positive or negative, but it's not negative. Well, by adding 1, we can actually use a negative 1 because its opposite is what's going to get it to 0. So that's why we add that negative 1, and there's nothing to the left that's there. If you wanted to get really fancy, that's where your asymptote would be at, because we're getting nothing to the left-hand side. I can't plug in something like negative 7 or negative 10 because I can't take the square root of a negative number. All right, that's it. We'll see you.